Yesterday we were looking at just exponents in general and what an exponent means. So like right here, 2 to the 3 is 2 times 2 times 2, and 2 to the 2 is 2 times 2, right? Two twos. And we did a bunch of work with some exponent laws. When you multiply powers with the same base, what do you do with the exponents? You add them. When you're dividing powers with the same base, what do you do with the exponents? You subtract them, and then powers of powers, you're multiplying the exponents. Those are sort of the three exponent laws. Pretty straightforward, pretty easy, I think. Most people are comfortable with it. Until you start to mix it up with other stuff, it does get a little bit trickier, but won't be too bad today. So here's a question. Whoa, what happened? Uh-oh. OneNote's crashing. Great. Oh, we're covered. What does 2 to the 0 equal? Do you remember this from grade 10? You saw, or grade 9, sorry, you saw this in grade 9. Don't tell me the answer, but you remember? Okay? You could do it on your calculator. This is a nice one because you could always cheat and just use your calculator to remind you what it equals. Some people might say, oh, it's probably 0 because 2 times 0 is 0, but it's not. So let's explore and see if we can figure it out. It's always nice. I talked about this a little bit on the very first day of school, I think. It's always nice if you understand why something is true, because then you don't have to memorize it and remember it. You can like recreate it when you need to. Next year when you're doing math and you're like, oh yeah, powers of 0 or an exponent of 0. What is that? Well, I remember how we did it. Oh yeah, and you just figure it out. Or on the test, if you're not quite sure, you can kind of figure it out, right? So it's better to understand. So there's two ways I can do this. We're going to do it both ways. 2 times 2. We didn't do this yesterday. I think we might have seen it on a sidebar, but that was it. Over 2 times 2. Is that right? Now, there's something that we can do. If you're not comfortable with this, take my word for it. This works. Only works when you're multiplying. If I was adding something on the top or the bottom, I couldn't do this. But since everything on the top is multiply and everything on the bottom is multiply, I can actually go zip, 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 zip. And what am I left with? I'm left with 2 over 1, or 2. And what was the rule yesterday? Dividing powers with the same base. You subtract the exponent. So this is also 2 to the 3 minus 2, which is 2 to the 1. And this is, of course, 2 is 2 to the 1. That's a nice little thing to remember as well, because I think it came up in the practice. Some people forget that a little bit when they need it. So what did we just notice there? Oh, we noticed that doing it both ways worked out to the same answer. To better, that's math. It's supposed to always do that. As long as you follow the rules, even if you go one direction or a different direction, you eventually get to the same place. And do you see how we did it? But what does this have to do with 2 to the 0? Well, let's try another one. What about 2 to the 3 divided 3? So we're going to do it again, 2 different ways. This is 2 to the 3 minus 3, which is, 2 to the 0. Right? What if I did it like this? 2 times 2 times 2. 2 times 2 times 2. So what happens here? These two cancel. They divide to 1. These two divide to 1. Cancel each other. These two divide to 1. They cancel each other. I'm left with just a 1 on top, just a 1 on bottom. So that's 1 over 1, or 1. So those two things must be the same. And therefore, we say 2 to the 0 equals 1. Or in general, if I have anything like a to the 0, so a can be anything, it will equal 1 as long as there's one little condition. You don't have to worry too much about this, but it's a technicality. As long as a doesn't equal 0. 0 to the 0 is not 1. But again, that's not something that we need to worry about. But just to be perfect in math, we like to make those statements like, except for this situation. But in every other situation, a could be anything. Could be a decimal, could be a fraction, could be a negative number, could be anything. You raise it to the exponent of 0, you get 1. How many people remember that? Now that we've seen it, it's kind of familiar. Okay, some people do, some people don't. That's fine. Any questions on that? That's that. We're going to do some examples with it, but that's it so far. Ooh, what about a negative exponent? What, Sarah? Ah, that's a good guess. And that's a lot of people's gut feeling intuition is, does it make the result negative? So I don't know. We're going to explore and we're going to find out. And again, this is where like hopefully the understanding comes in and we'll find out what it does. And folks, what I can tell you is having a gut feeling about this stuff is key. You should have a gut feeling. You should do a gut check. I think this is what's going to happen. And then you find out if you're right or wrong. And if you're right, good, go with your gut next time. If you're wrong, then you know that for this, you can't just go with what seems to make sense. Does that make, you get what I'm saying? Like sometimes on a test, you get a little bit nervous and you forget and you're like, oh, okay, so now I got to try to figure it out. Do you go with your gut or not? That's what I'm saying. All right, so let's try this. We're going to do the same thing. 2 to the 3 divided by 2 to the 6. So this is subtracting exponent. So I'm going to go 2 to the 3 minus 6, which is 2 to the negative 3. So that's what we want. Do you agree? See what I'm saying? And now we can use our little trick over here. 2 times 2 times 2 over 2, 1, 2, 3, 4, 5, 6. Are we good? Do this canceling trick. So I'm left with just a 1 on top. And what am I left with on the bottom? Two times 2 times 2 is 8. But more importantly, how could I write 2 times 2 times 2? Very nice. 1 over 2 to the 3. I'm just going to fix that. 3. So what happened here? Which is, by the way, I'm gonna put it here like in brackets maybe, which is 1 over 8. So it's a fraction. It's not negative. A negative exponent didn't make the base negative, and that's an important rule to remember. It doesn't, but it's an easy mistake to make. Like, even though we talk about it and we show it and I tell you this and we practice it, still some people go back and make that mistake. Okay, so be mindful. Negative exponents do not make the result negative, the base negative or anything like that. It turned it into a fraction. Okay, so I'm going to write out a couple things here. Therefore, 2 to the negative 3 was equal to 1 over 2 to the 3. This is a pretty big idea. It's pretty important. It'll come up a lot in this course, and we're going to practice it quite a bit over the next few days to make sure that everybody's had enough time for it to really sink in and you understand what it means. Okay? If you don't quite see, like that surprises you and you're like, okay, I mean, I believe what happened there, but I don't really get it, that's okay for now. Okay? You can look back at it again later and try to kind of figure out why there's other ways that you could look at this stuff. But really what we want to know is we want to know that a negative exponent is going to give me some kind of a fraction thing going on. So in general, we're going to write this down again. If I have a to the negative m, I'm going to get 1 over a to the m. And there's one more way that this sometimes looks. A over b to the negative m. So what's different about this one is the base is already a fraction equals b over a to the positive m. So I flip the whole fraction. And just as another reminder, it'll come up today, but this is b to the m over a to the m. That's how you do exponents with fractions. Any questions about any of this? Don't write this down. I'm going to just show you a couple things, and we're going to do some examples. So when we had like 2 to the negative 3, that's kind of like 2 over 1, right? Well, it is like that. We don't write it, but it is. So that's why it's 1 over 2 to the negative 3. Or if I started with 1 over 3 to the negative 4, I would flip that to 3 over 1 to the negative 4, which is just 3 to the negative 4. It takes whatever your base is and flips it. Whether it's a whole number, a fraction with a numerator and a denominator, no matter what, flips the whole thing.